So hello. Let me just get my speaker notes here. My name is Jason Sendelbach. I'm a Senior Director of Engineering at Sprout Social, and my pronouns are he, him, his. And we're just going to go over a general overview of software disciplines, and then some basics. And especially as you all are, kind of like in the high school range, we're to start, talk a little bit about building software as a team, and then how to stand out when finding a job. Some discussions around what to do to select a company to work for. And then also if you're college bound, I have some ideas and some advice. So you can do with what you wish with the advice. So a little bit of my path in software. I was born and raised in the suburbs of Chicago, and ended up going to the University of Illinois in Champaign, where I majored in mechanical engineering. And I graduated in '99, so it's over 20 years ago. At that point, computers weren't really accessible. They're very expensive, so I didn't have a computer other than like a Commodore 64. So there wasn't really access to computers. So when I got to college, I realized I really loved computer science. I took a number of coding classes, and I'm like, ooh, I like this. But in order to switch, instead of graduating in 4 years, it would take 5 or 5.5, something like that. So I didn't have the money to extend my career. So I just finished up in mechanical engineering. But as many free electives as I could, I took in computer science classes. That got me into a spot where I really wanted a computer science job, but like companies like Microsoft wouldn't talk to me because I wasn't a CS major. So I went into consulting, where I worked for a number of years, really integrating companies' existing systems with software that they're purchasing. And I worked at a lot of different companies, and it gave me the insight into what I really liked about companies and what I didn't like about companies. And as a consultant, I was kind of a temporary worker there for 6 to 12 months, usually for a project. After that, I went independent contracting. So I started my own business and basically was working as a software engineer for hire by the hour. And it was really fun. A couple of things that it taught me was, number one, how to run a business and all the accounting of payroll and those kind of things. But also it really taught me of every hour that I worked, I was getting paid for, and I looked at how much I was making per hour. And so it was hard for me to take a day off, right? Because I'm like, oh, that's how many hundreds of dollars am I not going to make if I don't work, right? And then the other thing was that I always had to keep my resume up to date. So I was constantly networking and doing job hunting, which is actually a good thing. But it was definitely different than just working at a normal company. The other thing I realized is that it kind of capped the roles that I could do. So companies wouldn't want to hire me as a consultant to be a leader at their company because they wanted someone full time so that they'd stay there a long time. So I basically was kind of maxing out my potential of what I could actually do as an engineer. So at that point, I switched to a product company. My first one was at Grubhub. And I started, I think I was like an engineer number 10 or 11 or something like that. And then saw them through the merger with Seamless Web in New York. And then we ended up going public, which was very fun. And after Grubhub, I basically went to a couple small startups in Chicago. They both failed, as a lot of startups do. And I think it was mostly about how the leadership of those startups is really motivated by profit and not about building really great software that customers could use, and building a really great team that could build software. And then I found Sprout Social, where I'm at now, and I really love the culture. And what I really like about it is that our leadership is really well intended, and the kinds of things that we do are really making sure that we're building awesome software for our customers and solving their problems, but also really building a great team and making sure that our employees are really top priority, which is really great. So in terms of software engineering, there's, in a nutshell, there's code, there's data, there's problem solving, right? So you're using languages, writing syntax, using frameworks to solve problems. But a lot of it, no matter what industry it is, whether it's food delivery in Grubhub or Sprout Social, which is social media management software, you're retrieving data, storing data, manipulating data. It's all about moving data around and making sure that you can control that data. And in a nutshell, computer science is really problem solving, right? So it's what problems are businesses having, our users, customers, as well as what are the constraints of existing systems and the limitations of certain software concerns. So I look at software as like the three main disciplines. This isn't a full list, but in general, software engineers are usually building web apps, mobile apps, or the platform and backend. You can definitely specialize in some of these things. So like on the back end, you might get very into some nuances of databases, data stores, search indexes, those kind of things, or getting into frameworks like Redux or Spring or those kind of things. So we're always building tools that kind of help each other out in terms of building software solutions. Another note is there's a lot of user-facing things. So if you're really intrigued in the actual interface design, there's a lot more of just building software. There's UX, UI, and design. And I see UX as really trying to solve the problems that the user is facing. So how we do that with software is really understanding what is the user trying to do, and is software the right tool, or what parts of the problem can software help with? And then the UI is really more of information architecture. How do we lay information out? How do we put the controls? And then design is, I look at that as more of like the art form. And so all three of these things together really make a cohesive experience for the user. And then there's a lot of software that needs to get built once we know what kind of experience we want to build. So in terms of the basics of software, right, you have the language syntax, right? So this is understanding the capabilities and limitations of each language, learning control statements and flows and iterations and collections. Then there's object-oriented, which is really helping you to make sure that you can reuse things and make sure that you don't repeat yourself constantly. What kind of patterns can you use for more of an elegant design? There's a note about pointers and garbage collection. So I think that as a new engineer, sometimes it's really hard to wrap your head around memory management, and certain languages, you have to actually alloc and dealloc memory. A lot of languages do this for you, but it's doing that with some costs of garbage collection and some routines. So understanding pass by value and pass by reference and the way that the underlying language works is very important to make sure that you're not building something that's going to get very bloated and constantly just overweight in terms of the memory usage. So it's really important to kind of understand that what's happening under the hood. And then there's frameworks, right? So like what language or what capabilities or features does the language have in terms of the elegance of iterating over collections and stream processing and those kind of things. And then there's a lot of like open source frameworks that are usually tied on to certain languages that really help you build things in your discipline, right? So on the back end, for Java, there's things like Drop Wizard, or with Python, Django for like a RESTful web experience as well. So the other things are collections, JSON, and REST API. So collections are, it took me a while in actually building software to realize that it's all about collections, right? So you have lists of data that are sorted, or sets that are unique, or maps with keys and values. And then you have collections of collections. And so it's really helpful to understand the capabilities of these collections and how they can scale and which kinds of collections you can use in certain scenarios. And then JSON is really nice because when I started, it was XML, and that was less than fun to work with. But JSON's really nice because it's a very lightweight way of encapsulating data that's self-describing. And it allows you to share data between like a server and a client and not have to have a whole bunch of information around it. It just kind of naturally lends itself of like, hey, name is Jason. And that's pretty easy to kind of figure out. And then the REST API, this isn't the only way to communicate between kind of clients and server, from web and mobile apps to a server. But it's basically the de facto standard with our current kind of web standards. And it allows us to do some really great things with some patterns, so that as new engineers go onto a new project, you can kind of just sort of pick up and be like, oh yeah, I get it. Like it's RESTful, so I understand how this is working. So in general, like, where do you start, right? So a lot of you have some computer science classes that you're taking. In general, I look at it of, if you're on platform or backend, I really like to just sort of pick a language, and I prefer Python and Java. In my opinion, I think Python's a little easier to kind of wrap your head around as a new person that's kind of getting into computer science. Java's really great for production systems, but there's it's a little more clunky in terms of writing code, and it really helps if you have an IDE for Java, where Python, you can get away with the text editor. But what I like to offer out as a suggestion to new people that are learning how to code is come up with some examples of problems to solve. And so I usually go to a CSV file. So open up a spreadsheet in Google Sheets or Excel or whatever, and put your names and addresses of some context, and then save it as a CSV. And take that file and with Python, read all of the lines and parse out the data and answer some questions. So like try to figure out, spit out every person that in your contact list that has a Q in their name, or everyone that has a 4 in their zip code or something like that. And so what it forces you to do is learn how to read from files, parse out data, put it into objects, figure out how to use collections to find those things, how to sort by things, how to search things, right? And so it's forcing you to kind of learn how to apply the language, which is really important. And then if you're like really great at that, build a REST API, right? So use Dropwizard or Django or something like that to try to just sort of list off some data that spits out some JSON. And so like that's the kind of like path I usually take of when I'm trying to learn a language. On the website, the languages are probably more in JavaScript, but I usually like to kind of build something in a React framework or something that's more of a web standard for the web community. And then again, instead of just starting with some sort of like server that you're talking to, just create some JSON, like similar to the CSV file. So create a JSON blob with an array of your contacts, and then start using that data in the web, right? Create a button that spits out like a random zip code or something like that. So just create some problems that you need to solve so that you're getting better at applying code. And in the mobile, I think this is probably limiting to, number one, if you have a Mac and if you have an iPhone. So depending on which one, you can always install the SDKs for whatever you have access to. And then, build a UI, right? And start with some hard-coded JSON data, and then start manipulating that with the controls of the mobile app. And I think it's really important to understand the nuances and the capabilities of the framework that you have. And then again, like if you want to make a more advanced thing, you can hook your mobile app into calling an API. So in the real world and in the business world, building software as a team, and I think you're all kind of experiencing this in a hackathon, right? So you're all paired up with team members. Writing your own code is easier, right? Because you're the only person that needs to read it. But as soon as you start working with others, there's some issues that come up, which you're all probably kind of encountering, right? How do you coordinate the work? So who's going to work on what? Does everyone agree about why we're doing this and what we're trying to achieve and how we're going to get there? It's really important that those kind of discussions happen as a team, and it's not just kind of some sort of decree. And then maintainability. So I think as you're writing code, you can create a variable x equals 3, right? And you're passing this variable around. But then if someone else on my team has to read that, they're like, what is this x? And so they ask me, I'm like, oh, that's the number of people that have logged into the site. And I could probably just name that variable number of people who have logged in the site equals 3. And just the art of naming that variable or naming your method names or your classes in a way that is self-describing really helps the team that you're working on. And then in terms of documentation, it's adding documentation to help clarify the context, but trying to make sure the code is as readable and self-describable as possible, and you really don't need documentation. And writing good tests is a really great way of helping document the behavior that you've intended with what you're writing. And the last thing I'll say about teams is buy-in. This is something that I give a lot of advice to a lot of engineers as an engineering leader. Is a lot of engineers, we are inherently problem solvers, right? So we see a problem and we want to fix it with some code. We're zealous, we're like, I'm going to build some code to fix this problem. So you see a problem and you fix it, and you spend 4 hours and your head's down, and you fix this thing, and you bring it to your team, and you're like, hey, look at this. And they're pissed off because they think that you've wasted 4 hours. And why do they think that? A lot of times they disagree that that's the problem that's most important to us as a team. So in a team, we have limited a number of hours. There's always too much work to do. So we always have to balance what's the priority for the team to work on and what should we be working on. And so the engineers usually skip getting that buy-in about, hey, team, I see this problem. Is this the important thing for me to work on? should I go spend a half a day work on this? And if you have that buy-in, usually the solution is pretty well received. Then the other error is, oh yeah, I buy in, and then you go do it, and then you kind of come up for air, and you're like, hey, look at the solution, and people are like, well, why'd you do it that way? Or what? That's not going to work with this other system over here. So getting buy-in on your approach to what you're going to do, of, hey, I'm going to do A, B, and C. And someone on my team, Joe, was like, hey, B is not going to work because of this other system, but you could do A, this other thing, and then C and D. And so like getting buy-in from your team is incredibly critical, but it's usually counterintuitive to the way that engineers want to just kind of solve a problem on their own, kind of prove to each other that they're a good software engineer. So again, working in a team is different. So as you're honing your software skills, hone your interpersonal skills as well, and try to just empathize with those on your team of how would you like this to kind of experience, or how would this experience work for you? And then some advice on how you can stand out when applying for a job, right? So as you go through your learning in software, whether it's in college or on your own or in a boot camp or wherever, you won't have a lot of experience writing code, and you'll be seeking a job to build some code, or your experience might be in hackathons and stuff like that, but not real kind of business world experience. So in general, I would say practice using Git. So being very familiar with the interactions of the source control system. Git is pretty much the de facto standard across the board now. Whatever language you're using, you're going to have to share your code and issue PRs and merge it into the main branch and do some production deployments. So getting really good at using Git is imperative. Working with a team member is great, because then you can practice the art of PRs, and then what happens if there's conflicts. So you both go edit the same method and see what happens and see how you can resolve those issues. Getting practice at that is really invaluable. So you can definitely create some GitHub repos. So like as you're learning how to process a CSV file, open up a public repo in GitHub and write your code and keep on checking it in and pushing it up, and so the whole world can see. And that really helps demonstrate to future employers of, hey, this person knows how to code, and they've iterated, they worked in small chunks, and they built this things out, and they know how to test, and look at their documentation. So it's really good, and it's okay if your attempts are rudimentary as you're learning, but just that exercise of actually trying and being just vulnerable of like, hey, look at these things that I'm doing and the things that I'm learning is a really help to separate you from the rest of your peers that are also competing for those jobs. There's a lot of open source projects, so follow them. If you're interested in some frameworks that you use, dig into the code. It's open source, so go look at how this works. Look at how people contribute to it. Maybe contribute on your own. Add tests, ask questions in the threads, comment on PRs. Just get involved in those communities, and that can really help you kind of stand out, in terms of your contributions to the open source community. And then build something, right? So from scratch, build some software. And it doesn't have to be something gigantic, or if your end vision is something gigantic, make sure that you're iterating. So you're learning about, how do I just process a CSV file? And then at some point I'll have an app that can display the data in that CSV file. And again, if you can partner with someone to learn how to work in a team, that's again, very invaluable experience that you can walk in to a company with. And then in terms of your communication in a PR, so I think like as the PR process is more of, hey, I want to add this code to our shared code repository. What do you all think? So the message that you put in there should be a very concise message of what you're doing and the scope of what you're trying to do, and maybe some assumptions that you've made. And then in the PR process, instead of just sort of saying, hey, change this to be A, B, and C, I tend to find it's a lot easier and more well received to ask questions of like, hey, have you thought about this scenario? Or what happens if something like this happens? And let the engineer that is writing the code and issuing the PR kind of get to what you think is, A, B, or C, or X, Y, and Z. And eventually it's more about the dynamic of the interpersonal skills. So how are we making sure that the best ideas win and good production software is winning, rather than, yeah, this code is perfect, right? And just sort of like being vulnerable and being willing to accept feedback is pretty critical. And then in terms of just you and your career, networking is key. So make sure that you all create a LinkedIn profile. Make sure that you add all of these hackathons and activities that you're learning, any volunteer opportunities, keep on adding to that. And create a network. So when you attend hackathons like this, make sure that you LinkedIn connect with everyone that's attending, all the organizers. I'll put my link at the end, so send a thing to me. Just establishing these relationships is really helpful as throughout your entire career. When you're looking for a job or when you're trying to get people to join your team, it's very helpful to have that well-established network. So invest a little time, and it's actually not that hard to do. And then attend meetups and conferences like this one. A lot of them have free food, which is great. Some of them, the conferences you have to pay for, but if it's especially something in town, it's usually pretty cheap in terms of a ticket. And it's a really good way of not only learning something, but also just meeting with people and learning what people are doing, and just at the lunch table, listening to conversations of what people are doing in their jobs. And it's really helpful to understand and just sort of get a wider angle lens about the industry. Oh yeah, and then you can actually, if you have LinkedIn installed on your phone, just hand them the phone and say, hey, search yourself and add a contact. And that's usually easy way, instead of like, what is your name? Like, which one are you? Like, what's your email? And then as you're searching for a job in terms of what to look for in a company, I would say that culture is probably number one. Of you want to work there, right? So you want to work with people that are really great. And it's hard to describe, but it's usually a good way of understanding as you visit during an interview process. Like, how are the interviewers? Are they happy? Do they talk well about the company? Have you met other people at the company? Really understand how they operate and how they treat their employees, right? That's a really important thing. And then I would really stress a learning culture. Not all companies do this. They expect you to know software and figure it out, and that's why they pay you. But I see it as more of a, if the company is investing in you and investing in growing, that's a good sign, right? Making sure that you're well supported throughout your journey as a software engineer. And then mission, I think it's important to make sure that you believe in what the company is doing. And it's not always going to be like, you're not always going to save the world. But I look at something of like, if you were working at a tax software company, is it great? I don't know, but it's useful, right? Like, people need it, and they'll pay you to make sure that the taxes are filed correctly, right? So I think, like, as long as it's not doing something that you disagree with holistically, or that's evil, that's a pretty good spot. And then mentorship. So I think that mentoring others is a huge value to you and them. Teaching something is a really great way at getting better at it. And as well as making sure that the culture is an assumption of, we're always growing the team and making sure that we're investing in each other and lifting each other's skills. And so that's, is this an expectation at the company that you're joining? And then if you're college bound, here's some just general advice. Take a statistics class, or maybe you can take it in high school, but this is probably the best math class that, most applicable math class. I took differential equations in college. That doesn't come up as much, but statistics comes up constantly in terms of business data of, hey, can we actually discern these insights from this data? And then also statistically of, how is our software working, and can we empirically prove that we're improving performance? So definitely statistics is a worthwhile class, and even take a couple of statistics classes. I'd also recommend maybe taking an accounting 101 class. This isn't the most glamorous thing, but it's a really great way of understanding. Every business needs a great accounting system. Every business needs to make money. So if you can understand that and be able to kind of make some parallels into the software world, it'll be very invaluable. This is something I wish I'd done. This is something of, can you learn another language? Can you go practice it? Can you go study abroad? Especially while you're okay with eating on the cheap, and food and transportation and lodging, cheap options. So definitely now is the time. So if you can, definitely try this. Not a must-have, but something kind of cool. Although the other languages that you learn are Java and Python and those kind of things, but it's not the same. And then I think in general, just ask why. So question everything. So as you're learning things, understand the why. Don't just pass the test in these classes, but really understand, how am I applying this? Does this make sense? Why are we doing it this way? it'll help you kind of get a broader picture. And so in hindsight, I think in college, I was just in a hurry to kind of just get through. And if I had kind of paused and absorbed it, I think it might have been a little more beneficial. And then have fun, right? So when you enjoy your job, life is more fun. So making sure that you're always learning, always growing, always asking why, and have fun. And it's really great about software is that I like to do it. It's really fun to write code, and they pay me for it, so it's pretty nice. I think that's all I have. So I'm going to turn it over to questions. I see a couple in the Q&A, and let's see here. Which is the best language for backend? Did I answer that already? I think in general, this is kind of a personal question. I would say the biggest language out there in terms of business world are probably Java, .NET, and Python. I think there's Ruby on Rails. So there's some other smaller ones, but I think Java, C++. There's a lot of those kind of things. I think there's a lot of legacy systems that are in COBOL and like mainframe type stuff. I'm not saying that those are exciting things, but there's a lot of systems that run on that. But I think like I like Java the best because it's very scalable and it's mature and it's a little bit slower to get to traction, but it's very powerful. I really like Python, but again, this is kind of a personal thing. There's nothing wrong with .NET. I'm not a Windows person, or I haven't been in a while. There's another one about what is UX. I would say UX is user experience. So that's there's a lot to it, and I'm not an expert at it, so I'm sure you should ask someone else about what UX is. But it's the art of how do we design software that's usable? How are we solving the problems that you come to this app for? And it's not just, hey, I built some software and you just click this thing, right? It's more of a, hey, I need to solve this problem. How can I answer these questions or look at this information? How is it laid out? How is it designed? What interactions? What happens if this happens? How are you going to get back? When you're done, where do you go? Right? So all of those questions really wraps into the experience of using the software. Computer science or software engineering, I think this is a question, I don't know if you need to decide holistically now, but I prefer software engineering because it's more of a holistic approach of how are we applying software or how are we applying code. Computer science in my mind is more about getting into the bowels of how a compiler works and the nuances of atomic locking in a database and how do you create indexes and those kind of things. So I would say it depends on if you want to go really deep into, just you want to work for a database company or you want to work for, some big data processing thing. You just you solve really, really big data kind of problems. That's probably more computer science. But if you want to just apply building software for people to use, I probably would err on the side of software engineering. But again, ask other people. I'm one man's opinion. Why do we need version control? Okay, so if you're writing code and there's 7 of us writing code, how do we make sure that we can share our code? So GitHub or other version control systems are a way of having a repository where we can sort of say, hey, on this day and time, Jason added these lines of code to this file, and then Joe added something else, and Rayon added something else. And then making sure that if we're changing the same code, there's some capabilities of being able to resolve whose wins and how do we kind of merge these things together. And then the other thing is that we have a new version of software, right? So your Mac updates or your Windows updates every once in a while. There's new features, right? So how do we make sure that we can have code in production in one version and then we're building the next one, but there's a problem in production. We need to fix this before this version is complete. So how do we augment this version without releasing this other stuff? So the version control system allows us to work as a team and then make sure that there's specific versions that we can kind of isolate, test, modify independently. What to learn after Python? So this is more on the back end. I think it's really up to you of like, if you've mastered Python, the language, have you tried Django as a framework to build a web API or a RESTful API? Have you tried another language? Like if you've built an app in Python, can you build the same app in Java, right? If you build a web API or a RESTful API in Django, can you do the same thing in DropWizard and make sure that a client like a web browser or a mobile app that you call can talk to either of them and it gets the same result? So can you master your skills of solving the same thing with a different language? Or do you want to go deep? Or do you want to try a web app next and get better at JavaScript? Or do you want to build a mobile app? It's kind of up to you. Are there other git, add, commit, push, pull? What other git commands do team members often utilize? Yeah, so git is generally you're working in a branch, right? So there's the main branch, and you're generally that's usually what's in production, and then you basically will you'll create a branch of like, hey, I'm going to work on this feature, right? So you basically make a copy of that, and you work on a branch, and you're committing locally, and then you push it up. But then you also have to rebase all of the changes that my other team have moved into main before or while I'm working in this in parallel. So there's rebase, there's merge, there's pushing, pulling. I can't speak definitively to what are all of the git commands, but I think it's more about there's a lot of stuff that I do locally of once I have my software good, I just sort of get it up into a branch in GitHub. And then there's there's squash merging and there's the PR process that happen up in GitHub. I'm sure there's probably someone that is more in the weeds of shipping code a lot that could answer that question better, but those are the kind of high level. CSV is a comma separated value. So if you go to any spreadsheet, if you just go to Google Sheets and you create a spreadsheet of your names and addresses, you can export it to a CSV file. And it's basically, it has quoted tokens for each of the values in the cells, and they're comma separated. You can also separate it by something other than a comma, like tabs or pipes or something like that. But it's just like a very simple thing of, in the business world, you can ask any business person, send me a CSV of that spreadsheet, and they can do it. So it's a really good liaison between software people and business people. And you can get data that you can actually start accessing and using without a big barrier to entry. Opinions on learning to use Git command line versus GUI-based Git client, or build your own IDE. Oh, built-in IDE. Yeah, I think try all of them. So I think like having command line skills is pretty critical. In the IDE, I usually use that as it's a nice thing to kind of see the context of the code that I'm looking at while I'm writing commit. But in general, I usually do my commits to my local branch in my IDE to sort of see the code and describe it. And then when I'm trying to rebase and move it along and push it up, I do that all in the command line. The things I do in the UI are really just PR approvals or creating a PR. That's usually what I do in the UI. But that's my opinion. There's not one right way of doing that. Is Java the only language used for making software or applications? I would say no. There's a lot of languages out there, right? I think Java, in my opinion, is one of the most mature go-tos for the backend. I think C++ is really helpful when the garbage collection is an issue, right? So when you really need to control your memory management and really scale those kind of things, I think that's when C++ comes into play. Java is pretty good. Python, when there's interpreted language versus compiled languages, there's trade-offs, right? And so when there's, I think like C is the fastest. Java adds a little bloat there because it can run anywhere with bytecode. .NET is great, but it can only run on Windows. So there's a lot of trade-offs. So I can't say that there's a best one, but I think in terms of the business world, I think Java is one of the key players. I think Python is probably another one. There's other ones out there like Go, and but it really depends on the shop or the company that you're working at. Is vanilla coding encouraged or deprecated when working as a team? What about frameworks? Is vanilla coded? I don't know what vanilla coding is. That's just like trying things out. Sure, I'm not sure how to answer that question. But I would say if you're in working in a team, what I was trying to get at is you have to just sort of make sure that the team approves of what you're doing, right? And if you're writing some vanilla code, whatever that means, like, does the team kind of buy into that? Choosing frameworks, that's a team decision, right? And so you're not always going to win your arguments, right? Of like, hey, I want to use this framework. But it's more of like, are you giving the team the idea or the ability to weigh in on these discussions, right? I think that's what's important. in terms of what to learn first, machine learning or deep learning, I'm not really sure. I am not qualified to answer that. I'm not into the kind of machine learning, deep learning world, but there's a lot of data scientist people out there. They probably have better opinions there. So I apologize. I don't want to answer it incorrectly. How would you recommend how to converge into a career niche in computer science? How to converge into a career. I think it's really more of follow your passions, right? If you really like something, do it. Not all computer science and not all software engineering is glamorous. Sometimes you have to write some accounting integration code, right? I thought that was really fun, but some of my teammates are like, oh, we got to work on the accounting stuff. But it's more of, are you solving problems? And for me, my litmus test was, is this challenging anymore? Or is this I have to do this again, right? So it's like, are you upping your game of the complexity of the problems that you're solving? But it's really like, don't let anyone tell you you can't do something, right? It's more of, do you want to do it? Is it fun? Is it exciting? Are you learning? And can you get paid doing it, right? My favorite IDE is definitely IntelliJ. I use it for Java. I use it to write Ruby. I use it to write Python. There's like a data grip. So I pay for the IntelliJ Ultimate personally, and I just use it all the time. It's not the only one, but I really like the refactoring ability and the debugger. It's really great. A lot of the other ones that are out there are, and I think a lot of my team members use VS Code for web code. There's a trade-off to just using a text editor, right? There's a lot of capabilities that IDEs add, but when you're starting out using a text editor, just like removing all the noise of an IDE of just like, can I get the syntax work? Once you get that, then the IDE can kind of take you to the next level. Could you explain REST APIs more in depth? Yeah, so REST APIs, if you just Google REST APIs, there's a set of, it's kind of like the CRUD interface. So I want to look at a list of classes that the college is offering, click on one, so I need to view a detail. I want to edit this class description, so I want to update it, or I want to delete this class. So if you have a web app that has a bunch of data that you're looking at a list, there's some kind of paradigms in terms of, what am I doing to send this to the server? And so there's get requests you can do, there's post requests, there's put, there's delete. Those are the HTTP verbs that you use. And then there's data in the URL, or there's structure of sending data to the server. So REST APIs are really a protocol for how you communicate from a client to a server. Google around, it'll do a better explanation than that, but it's really more of the de facto standard of a server being able to talk or receive communication from a web or a mobile client. It's usually through an API. REST is a structure for that API. How to integrate Python and other languages with other languages. Usually, so we have, at Sprout, we have disparate systems, and some of them are in Java, some of them in Python, and there's some other ones, but those are big ones. So in general, the same systems are talking to common databases. So MySQL databases, Postgres databases, those kind of things, Hadoop for big data. Or they're communicating via messages. And so messages in distributed systems are huge, right? So there's these queues that you can send. So you can send messages on a queue, and anybody can receive them, and anybody can send them. Multiple services can receive the same message. And so usually you're basically sending data that's JSON or some sort of agreed upon format, like a protobuf. And it's basically the contract of the message format, so that the sender and the receiver can be completely different languages. But as long as they agree on the contract, this Python code can send it, and this Java code can read it. Is Python advanced coding? Yeah, I would say Python's advanced coding. There's a lot of frameworks. There's a lot of capabilities that comes with, but there's trade-offs too. It's interpreted compared to Java, which is, well, I guess that's also interpreted as bytecode, but it's kind of half interpreted. But like there's C and C++, which are compiled directly into, like the Linux machine that you compile it on, or the Mac machine that you compile it on, or the Windows machine. What is the best framework? I would say there's a lot of frameworks, but I would say that some of the prevalent frameworks in the business world, or at least the software world, are frameworks to build an API. So usually like Django for Java, Django for Python, Dropwizard for Java, There's other ones. I think .NET has its own a thing. I just don't know what it's called. So there's like, that helps you, that's written in code that allows you to have these standards and structures that you can use. But then there's also frameworks that you can use for testing. So there's unit testing frameworks. There's collection frameworks like Eclipse collections and other like Guava. A lot of those capabilities are getting pulled into the core Java language. But in general, the frameworks are really more of whatever is useful to you and whatever open source communities have built useful tools for you. Is a bootcamp imperative to becoming a proficient computer scientist? No, I think in general, becoming a best computer scientist is you writing code to solve problems. And how do you get that opportunity? Well, it's either you sitting at a screen and having the focus of trying to solve those problems, or doing it at a boot camp, which is kind of like a fast-paced kind of like, hey, let's just learn how to build some simple software, or more of a college program where you're really getting into more of a, not only in addition to computer science, but a more well-rounded education. I don't know if I can answer that question other than it's kind of up to you of how do you learn and what's going to be more beneficial to you as a person holistically. Can software development also help in growing business? Oh, absolutely. I would say in my role now, I'm a director of engineering, so I'm shipping less code than I used to. But a lot of times I'm trying to figure out like hiring or staffing. And so I get a bunch of data in a CSV file, and I'm actually right now putting in a database so I can query that, so that I can answer some questions for the business of like, how many people can we hire here? Or how many teams could we build if we had this much budget? So I'm basically using my software skills to answer business questions. And I think that being able to integrate with business people that know spreadsheets in Google Sheets or Excel, and software, of how you can bridge that gap and answer the questions is really important. So the use case of trying to figure out how to work with CSVs is pretty good. So one just got out of college. What does one do to get a job if one doesn't have connections or LinkedIn? Sure. Well, you can start by you could start by where do you want to live? So you could look for companies that are there. You could try to figure out what companies do you like that you're just like, oh, I'd love to work for that company. Are they a software company? Go try, apply, right? You can Google, I think Indeed, Glassdoor, Stack Overflow. Those are all really good places to look. And it's also like just where are your friends working or where are your contacts working. Try to establish a network, but yeah, without it, it's, you can definitely start Googling and you'll find jobs. But finding the good jobs takes a little more thought. So getting some other people to kind of weigh in would help. How important are grades in the academic side of CS versus projects and actual coding? This probably depends on the company that you're applying for. I look at your grades and your what school you went to as a last thing. That I'm usually hiring people with experience. So as an entry level, it's a data point, right? If you get A's or if you get straight A's, great. If you get A's and B's, great. If you're like D's and C's, it's like, well, did you want to be a CS? So I don't know. It's a data point. But I would say that regardless of your GPA, if you can demonstrate with experience and volunteering and learning, that can help boost up a lower GPA. Is Python sustainable for competitive programming? I'm not really sure what competitive programming is. Is that like a hackathon thing? I would say sure. Or is it more of a performance issue of like, is this scalable? At Sprout, one of our main edge APIs that our entire business runs on is in Python. So it's a mature production ready language. So sure. What are the benefits of Java? You need to compile it using a Java compiler, then run it using Java, and it's slower than C++, has to compile, but the compile is in binary, also it's fast. Yeah, okay. In my mind, the Java is superior because the memory management is handled for you in terms of garbage collection. I think it has, depending on the task at hand, there's certain things in the business world that I would only choose C++ for, and there's a lot of things that I choose Java for. I would say Java, script, Python, Ruby is an interpreter, but doesn't need to compile it slow. Yeah, so I think like in general, We have an Edge API that's written in Python, and it's fast enough. It's within the 100 milliseconds for a lot of our endpoints. So, how fast do you need to get it, and how important is the task at hand? There's certain code that like NASA writes, and that has to be 100% perfect, and it can't have the bloat of garbage collection, those kind of things. So sure, C, C++, some lower level languages might be applicable there. For trading applications, right, where you're like milliseconds count, yeah, don't use Java, right? So it depends on the task at hand. But in general, I see it as more of our computers are fast enough that the speed is becoming less and less important if it's really just a web app or a mobile app, something like that. So I think like, are you really, what problem are you trying to solve with the speed? That's my question there. What is pointers in GC? Yeah, pointers are, so like in C++, if you have an object, you have a memory reference that points to this object, right? In C++, you say, hey, I need this object, so give me this much memory. And when you're done using it, you have to say, stop using that memory. In Java, you point to this object, you say, hey, create this new object. And then when you're done with it, you just stop referencing it. And then Java will eventually go clean this up and garbage collect it. You'll learn more about this in computer science classes, or you can just Google it. But in general, it's important to understand what the capabilities of the language are doing and how it's working in the back end, so that as your app is scaling and there's memory issues, you understand some of the nuances behind it. Did you enjoy your experience at UIUC, and did you feel like it provides a very encouraging environment for aspiring programmers? Yeah, so I didn't go into CS there. I took a number of CS classes, so I can't weigh in on about aspiring programmers, but I think I liked it because it was, I didn't want a small school, I wanted a little bigger school, but it was big enough but small enough. So there were some classes that I took that were in like auditoriums a couple days a week for like Econ 101. But then you did that 2 days a week. And then the third day a week, you'd be in a TA class with like 20 people. So it felt like a small school, and you could ask very specific questions to the teacher. It's really up to you of like, what do you want in a school? Outside of just CS, what else do you want? What other kind of like clubs or activities or sports or those kind of things does it have? And as you're learning computer science, what other classes can you take? Like University of Illinois has tons of classes. I took ice skating, as one class. So like, what other kind of like well-rounded classes can you take? But I would say, yeah, it was a great school. But if you need a really smaller school, it's probably not the place for you. What do you value most in a creative developer? I would say a creative developer, I would say problem solving, right? Are you just doing what you know? Or are you always constantly trying to figure out how to solve problems in a different way? Are you tackling problem solving and applying code, and you're learning, and you're vulnerable? You're able to say, hey, this is what I think. Does anyone have a better idea? Getting rid of your ego is really important. And I value that a lot, because everyone, like all of us CS people, like we can figure out the syntax, but it's more of how do we apply it as a team, and that's the hard part. Is statistics and math required for software development? I don't know, probably. I don't know what the prereqs are, but I mean, in general, like if you look through the software, like the if conditions and or logic, that's all math-based, right? So having fundamentals in math is helpful. My point about statistics was more about, it is really helpful in a business sense, and also in software of like, can we empirically trust this data about our software? That's where I was getting at. And can we build games or maps using Java? I don't know. I can't imagine. Well, games, sure, but it would be like command line, maybe. I don't know. And then maps, I don't know. Java's really clunky at user interface, right? So I like Java as a back-end experience. I wouldn't recommend Java for games or maps.
Great. Well, thank you so much, Mr. Sendelbach. I think everybody
Sure.
learned a lot of amazing things, and thank you for answering all those questions. It
Sure.
took your time out of your day. And if we have any further questions, we can definitely direct questions towards your LinkedIn, I believe, email, all the information, good stuff. And yeah, thank you so much once again. I think we all.
Yeah, sounds great. Yeah, appreciate it. Yeah,
Thank you so
thanks,
much.
and
This was awesome.
good luck on the hackathon. I can't wait to look at some awesome projects coming our way.
Thank you.